So just quick revision. If you are given with the compound, which is trichloroacetic acid, clear? So this compound will be highly acidic than acetic acid or less acidic than the acetic acid. This is trichloroacetic acid. And this is just acetic acid, which will be highly acidic. Yes, Hridaya? Here the Cl group present in more numbers, correct? How many? 3. And what is the nature of Cl, Hridaya? It's electron withdrawing group. Today I will send you notes after the class immediately. No worry, okay? So EWG group enhances the, Hridaya, you can hear me, right?
Yes, ma'am.
So enhances the acidic nature. So more the Cl, more will be acidic. So we say this compound is highly acidic than this. Clear? Correct, Hridaya?
Yes, ma'am.
Let's start the other properties. We have first properties. So reaction now, these reactions are involving where we have a cleavage between carbon and oxygen bond, right? It means we can see carbon oxygen bond in the sense carbon oxygen hydroxyl bond. It is getting influenced. So involving over here the cleavage of carbon OH bond. Clear? So we explain here this carboxylic acids on heating with mineral acids like sulfuric or hydrochloric acid, such acids. Sometimes we use even phosphorus pentaoxides, right? They give anhydride. So far you have seen how we get the anhydride, say aldehyde, carboxylic acid. So vice versa. Even here the carboxylic acid produces the anhydride. Okay, so let's see over here. Acetic acid, I'm drawing in a structural formula. Here the OH bond, and this is connected with the 1-methyl group, right? Plus we have other side also the same group present, correct? But in a opposite direction. So that I can say the removal of the group in easy manner and we can understand better, right? Now look at over here. The cleavage will occur one OH group from the any one. You can even take from this, right? So it depends on like whichever side you wanted because both are identical, isn't it? So H2O goes out. Hridaya, are you able to understand? This happens in the presence of acid. So instead of writing sulfuric acid, what I have written over here is H plus. Okay? We are heating it in the presence of this. You have other option also, Hridaya. You can take phosphorus pentaoxide also. So when we take this compound and treat with this, we get compound anhydride. So anhydride ka formula goes oxygen attached, carbon double bond oxygen, here oxygen connected, and methyl both the sides. Hridaya, this reaction, are you able to understand?
Yes, ma'am.
This is called the acetic anhydride, or you can write the IUPAC as well, no worry. You can call this compound as ethanoic acid, correct? Because you have one carbon, two carbon present over here. So it can be called as ethanoic acid, correct? This also called as ethanoic acid. Clear? So similarly, we can call it as ethanoic anhydride. Right? Common name, Hridaya. What is the common name of compound? Acetic acid. So can we call it as the acetic anhydride? But this would be the common name. Clear there?
Yes, ma'am.
This is the one preparation where cleavage between carbon oxygen hydroxyl bond takes place. This is the first reaction we are reading. Second reaction, the formation of, you have seen anhydride, formation of anhydride. And similarly, formation of esters, we can say, from carboxylic acid. This is well-known reaction, formation of ester. This is called as esterification. So we know this reaction, carboxylic acid ke presence mein and alcohol, we get a compound. What do you call that as? The ester. So let's take over here C2H5 COOH. This is the compound treated with the C2H5OH alcoholic compound in the presence of acid, right? And we know water molecule goes out and we get ester C2H5, C double bond O over here, then again C2H5. So what do you call this compound as? Ethyl propionate. Whole completely it is called as propionate, right?
Yes, ma'am.
This is well-known reaction because like we have learned many times esterification. So esterification shown by the carboxylic compound. Next compound action or the chemical reaction, we can say it has an action with the PCl5 and the PCl3. So reaction with, we will learn together. Is that fine? Reaction with PCl3 and PCl5. So where we can find the difference also. What would be the difference between PCl5 product and PCl3 product? Okay. Let's do over here the first PCl3. Okay. R, we have taken COOH. Now number of R, COH depends on the how many Cl you have. Suppose you have 3Cl. Okay. We have taken phosphorus trichloride. That many carboxylic acid would be taken over here. Is this clear? So compound goes over here. 3 moles acetyl chloride, you can call, right? Acyl chloride as this compound we use in Riddlecraft acylation reaction, remember? And since there are 3 chlorine, already we have used all the chlorine atoms over here in the formation of acetyl chloride, right? This is also called as acid chloride. Don't get confused. Acid means HCl or HF for that. This is also known as acid chloride. RCOCl is the general formula. If you get confused, you can call by the other name acetyl chloride. That is also working, right? Is this clear, Hridaya?
Yes, ma'am.
Fine. Hridaya, still we have phosphorus with us, right? And how many oxygens we have? Let us write all these compounds in the form of phosphorus acid. What do you call this as? Phosphorus acid. Phos phosphorus acid. Okay. So this is reaction with the PCl3. Second reaction we will be doing with the PCl5. PCl5, the 3Cl will go along with the POCl3 phosphorus oxychloride. 2Cl will be equally distributed for the formation of, HCl and the acetyl chloride. So look at over here, RCOCl as usual, this product will be produced. But here the next product is phosphorus oxychloride, which is quite different from the phosphorus trichloride. And the byproduct, we get the HCl. Okay, so this you need to little compare and prepare, because here you get as the byproduct only phosphorus, but here you are getting hydrochloric acid ke saath. Always you get the hydrochloric acid over here. So hydrochloric acid ke saath we are getting the compound phosphorus oxytrichloride. What do you call this as? Phosphorus oxytrichloride. Let me write the name. Clear? And this is called the acid chloride or acetyl chloride. That's all. So we have two reactions, carboxylic acid reaction with the phosphorus trichloride and phosphorus. Now we can say pentachloride. Okay. So here we go with the next thionyl chloride, the next reaction. So fourth reaction goes with the reaction with thionyl chloride, SOCl2. Okay, Hridaya. So SOCl2 is called as, what do you mean by SO? In a no chemical name we call as a thio, like how we call azo nitrogen ke liye. Similarly, thio, word used for sulfur. Thionyl chloride. What do you call this as? Thionyl chloride. Okay. So thionyl chloride ka reaction happens with the carboxylic acid. It's all reaction just giving the acetyl chloride as the main product, I would say. When I show the reaction in a flow chart, that would be very easy for you because you will be looking there as the acetyl chloride with the phosphorus penta tri thionyl, all they produce carboxylic acid ke sath, all they produce what the compound acetyl chloride. That's a common product we get with all these halides compound, thionyl, phosphorus penta, and the trichloride. Right, Hridaya?
Yes, ma'am.
So here we go with the reaction carboxylic acid treated with the thionyl chloride SOCl2. What did I say? This also gives the SrCOCl. Like we know now, we are aware about this compound now. This is the acid chloride or acetyl chloride, anything you can call. So let me write over here acetyl chloride. Don't get confused, both are same. Okay. And since it is a thionyl, so we get over here as the byproduct. See, every molecule have their byproducts different. That's all you need to bother. So SO2 as the gas will be liberated over here and hydrochloric acid produced. Clear? So this reaction is happening actually in the presence of a base pyridine. So pyridine ke presence mein this reaction happens, we get as the acetyl chloride. Clear? We'll see all the examples once we complete this. So we have done all acetyl chloride related the reactions. From here we started and all we have done. So look at here the example. One example for this we will be taking. What did I say? As per seeing the number of Cl, we will choose the acetic acid ka number. Let us select 3. Clear? So can you just predict the product? What will be the product? Hridaya, we get the CH3COCl. Correct? This would be 3 moles. Hridaya, is this clear?
Yes, ma'am.
And what do you get other product as H3PO3? Phosphorus acid. So this is as example I am giving you. I will highlight. We have done this as example. Clear, Hridaya? The next example for this as acetic acid and phosphorus pentachloride, PCl5. The product forms over here same, CH3 COCl plus POCl3 plus HCl. Hridaya, it is clear to you?
Yes, ma'am.
So this is example area where we have kept examples. And for this, we have example over here. Acetic acid reacts with the thionyl chloride, right? So the compound here we get as CH3COCl plus we get the byproduct as SO2 and then hydrochloric acid. Hridaya, it is clear?
Yes, ma'am.
So Hridaya, just remember one thing. If we have, I will just highlight PCl3, PCl5, and SO2, SOCl2. So these compounds will be reacting with the acetic, with reacting with the carboxylic acid, and they produce the acetyl chloride. That concept is clear, right? Is this clear?
Yes,
So
ma'am.
it is clear right now. So let us move on to the next reaction where we can see carboxylic acid reaction with the ammonia. So reaction with ammonia, it is different. So I'm making another category for it, reaction with ammonia. Aldehyde and ketone also you have seen reaction with ammonia and its derivative. So here only the reaction with ammonia we will be learning, not the all derivatives we are going to see. Here only ammonia. So ammonia, how it reacts with this, since why ammonia reacts, let's know the reason behind it. Because ammonia contains a lone pair of electron, and we have the acid, carboxylic acid, free hydrogen available with it. That free hydrogen taken by ammonia and it forms the ammonium, isn't it, salt. That's the reason they show the reaction. So it is a kind of, you can understand in that such a way where the acid reacts with a base, right? So we take the carboxylic acid and treat with the ammonia, NH3. Will it, what will produce the compound as? Tell me. Acid. Okay, RCOONH4 plus. So it is quite easy now. You can understand in this way. RCOO, this is the free hydrogen. Let me highlight. This is the free hydrogen. And we have over here NH3 with the lone pair of electron. We consider this as an acid because it is ready to release hydrogen, and this is ready to accept the hydrogen ion. Are you clear? So we consider this as a base. So what type of acid base they are actually? So this is called the Lewis base, and this is as per the we can say Bronsted, it is giving out proton, so we can call it as an acid. So they show the reaction and they produce a salt. What is the salt over here? Ammonium salt. Is this clear, Hridaya? So this, you can see hydrogen is accepted by NH3. So when NH3 takes the hydrogen, a coordination bond will be generated between these nitrogen and hydrogen atoms. This is called the ammonium structure. Are you clear, Hridaya? This is for your information. I will keep over here. Are you clear?
Yes, ma'am.
Okay. So this is how, why ammonia accepts proton, because it contains lone pair of electron and hydrogen ion with the lack of electron. So that requires one pair so that it can complete its duplet. So they can form a bond, and the bond nature will be coordinate bond, not covalent, because pair is moving from one side. The donor atom is nitrogen and acceptor atom is hydrogen. Since hydrogen enters in ammonia family with the positive ion, the whole family means the nitrogen acquires this positive ion because it's sharing its lone pair with hydrogen. Are you clear? So the whole sphere will contain the positive charge. Are you clear, Hridaya?
Yes,
So
ma'am.
keep this side for your reference. You can understand while reading the notes. Okay, okay. This is I meant to say. Acid reacts with a base, gives a salt. So what do you consider this as acid? You know, it is a carboxylic acid. Ammonia is a base because it contains a lone pair on it. So it's a Lewis base. Due to lone pair, it is a base. So the product is produced over here is ammonium salt, right? And this ammonium salt, again, it is be like, it is not a stable. It will lose, like, which on heating, if we just heat it, what happens? It will lose water from it, and it goes in a form of, because a structure, look at here for your reference. I'm teaching over here, it is carbon double bond oxygen over here, right? And we have NH4 plus. Okay. So we know what happens basically. Here we have the hydrogen ion, right, along with the NH4 plus, that is coordination bond with the NH3, I would say. So this compound hydrogen gets free, taking oxygen along with it, and ammonia, right, amine group, as the amine group will be they taken. So how it works? Look at over here. I would draw the structure. So 1, 2, 3, the third oxygen we can, the bond which we have over here, it is showing the extra, right? Nitrogen ke paas we have basically the 3 valency, but here it works with the extra hydrogen ion, right? That is showing the total number of, we can say, valency getting disturbed. So what basically we do, we put negative over here so that it can balance its charges. So basically, when we show the bond formation with the water molecule, so basically how it happens, look at over here, this pair, this hydrogen will be moving away, whichever, like this covalent also can move, no worry, all identical now here it is considered. So this can move, right? So here the movement will be for two hydrogen atoms moving, because we have fifth hydrogen also present, sorry, fourth hydrogen present over here, that also moves out. And we can say anyhow we have removed this one, so leave this part. So two hydrogen with the oxygen, correct? So this gets its electron back, because these two are going back to, so oxygen gives electron, because taking, right, it goes out in the form of oxide ion, and these two are hydrogen H plus, so they form as water molecule. Are you understanding? So compound, what is left over here with the holding positive ion, and here we can have a lone pair of electron. So we can say the bond will be formed between carbon positive and the lone pair as a single covalent bond. So what do you get as the product over here? Amide RCONH2. Okay. What we are seeing, the loss of water molecule. So when we heat it up, we just see the loss of H2O from it. That's all. And we get the functional group. What do you call this as? Amide. Clear? Hridaya? So ammonia, when it reacts with the carboxylic acid, it produces ammonium salt. On heating, it loses water and produces amide compound. Okay. Now this you try to write by yourself. Example reaction. CH3COOH treated with ammonia. What will be the product? Hridaya, write this. Refer this one and write the product. Yeah, Hridaya, any confusion? You need to just release hydrogen and bring it over here. So CH3 COONH4.
He thought I'm undermining your record. That was number one.
You don't need to think too much. ठीक
Yeah.
है? Yeah. And just on heating, what will happen? Will change into the other compound? Yes, it will change into amide. Correct?
Yes, ma'am.
Vidya, are you getting concept? So we call this as the ammonium acetate. And this is acetic acid. Clear?
Yes, ma'am.
So what do you get as the product, Hridaya? CH3CONH2.
Yes, ma'am.
Are you able to understand?
Yes, ma'am.
Okay. The next reaction, now we will learn where complete group COH group will be involving. Reactions, right, involving complete carboxylic acid group. Okay? So let's do over here. So carboxylic acid completely involving over in all these reactions. We are going to learn, Hridaya, this topic. So before this, what did you learn? The reactions involving COH bond. You can see here, I would say this is the I means part where this got influenced, right? Then we have seen over here as well, here OH group coming out. Clear, Hridaya? Is this
Yes,
clear?
ma'am.
Then in this also OH group is involved, correct? Because the loss of what we can see, we left what we have with carbonyl in all these halide compound till here. Then reaction with ammonia also, when you see this compound is only getting influenced, right? And we are left with the compound carbonyl, correct? So now next part, second part, I would say the reactions we will be learning where carboxylic group will be involved. Okay, carboxylic group will be involved. So RCOOH, this is carboxylic acid. So this group gets into the reverse order. Jaise we get the alcohol say aldehyde, aldehyde say we get the carboxylic acid. So these are in a chain reaction. Like if we wanted to prepare aldehyde from alcohol, so what do? We do the oxidation by K-4 and K2Cr2O7 and we get aldehyde, isn't it? Then similarly, what you do with the compound, if you are treating it with the, let me take CH2 over here. Okay, so we if we want aldehyde say carboxylic acid, we will be doing oxidation like chain reaction. Okay, so we get aldehyde say carboxylic. Now if you want the reverse orders, then what you will do from carboxylic say aldehyde, if you want, then you go for the reduction process. Are you getting my point? What I have to do? Reduction. Okay, so first what did you do? Added oxygen, and now you wanted to remove oxygen. Quite obvious, because here we have two oxygen and here it is only one. So to do the reduction, so reduction done in the presence of reducing agent. What are the reducing agents we have? Like example, lithium aluminium hydride is the reducing agent. One, we can do this, correct? Hriday, are you able to understand?
Yes,
Like
ma'am.
how we have KMNO4 as the oxidizing agent. Correct, oxidation reaction. Basically, this is representing. So oxidation happen in the presence of oxidizing reagent. So when you do the reaction with the in the presence of oxidizing reagent, what happens? It go for the aldehyde and then carboxylic acid. Similarly, if you do the reduction process, it go to the reverse order alcohol. Okay. So we get the reduction, say we get directly actually into alcohol form. So we have an option changing it into alcohol. Carboxylic acid can be converted into this by treating it with the reduction reaction. Are you able to understand, Hridaya? So this is the whole process. Let this step to be written for your reference. So you can refer, okay, how this helps functional group in vice versa for preparation. So let it be. Okay, let's see the reaction over here. The first reaction, carboxylic acid RCOOH will be treated with the reducing reagent like lithium aluminium hydride. Okay, lithium aluminium hydride in the presence of ether, right? And this even can be followed by the hydrolysis, acid hydrolysis H3O plus will produce the compound as 1 degree alcohol RCH2OH. Clear? Is this clear, Hridaya?
Yes, ma'am.
Are you able to understand?
Yes, ma'am.
Okay, so you write the product from this RCOOH, okay, lithium aluminium hydride, the first, and second step is acid hydrolysis followed. What will be the product for there? See, number of carbon will not disturb, will be as it is. COOH की जगह CH2 आ जाएगा, that's all, and OH will be. That's all. Okay, so what will be the product? If I write like this, Hridaya, will be very convenient to you to understand. Carbon double bond oxygen. This group converting into the CH2. So we get over here CH3, CH2, and the OH. Are you able to understand now?
Yes, ma'am.
What is reduction? Removal of oxygen, addition of hydrogen. So that is happening over here. We are basically what we are doing over here. Which process are we doing over here? Reduction by reduction. Are you clear, Hridaya?
Yes, ma'am.
Okay. So can you do the next question by yourself?
Yes, ma'am.
Do this one. Yes, Hridaya. Do this reaction.
CH3, CH2, C,
This
CH,
whole group goes
CH2,
into.
CH2OH.
Very good. Have confidence, develop confidence. No worry. You have learned the concept, right? This is going in, getting into converted into CH2. So we will have a alcohol. This will be as it is. This is not disturbing. So we are removing oxygen and adding 2 hydrogen because double bond it has. This has to be maintained by monovalent. So we will like replace oxygen double covalent bond by adding up 2 hydrogen atom because hydrogen is monovalent. Okay? I hope you have understood.
Yes, ma'am.
Well done. Now, next reaction, we have this decarboxylation. So you are done the reduction and now decarboxylation. Second reaction under the reaction we're involving COOH group completely, right? So let's do over here. D, the reaction name is decarboxylation. D means loss. So carboxylic acid losing carbon dioxide, CO2. Okay, and that goes in the form of carbonate salt. Look at over here how it takes place. Very simple reaction, decarboxylation reaction. So we take carboxylic salt, carboxylate that basically. So we can say sodium carboxylate can be taken as the sodium acetate can be taken, sodium ethanoate that is called as sodium propionate can be taken. All such compounds can be taken and shown the decarboxylation, right? So we get over here CH3, COO, sodium, right? Sodium acetate. Okay, we call this salt is taken and treated with the soda lime. Sometimes they ask what is soda lime. So let me tell you, soda lime is a combination of NaOH and calcium oxide. So why do we take calcium oxide? Because the salt which is produced over here, it is very hard crust nature. So to avoid the blockage of the glasswares, that we use a base calcium oxide. Okay. So all together you can now count how many sodium? 2. So we'll write Na2. Carbon 1, oxygen 1, 2, 3. So we write CO3. Now you can see loss of CO, right? Carbon dioxide comes in the form of carbonate salt. So we say this reaction as the decarboxylation reaction. Are you able to understand, Hridaya?
Yes, ma'am.
And yellow part goes out. I am shading in a blue color. This blue color gets attached and gives a product as methane, CH4. Clear? So how do you prepare hydrocarbon from carboxylic salt? Simple, by decarboxylation reaction and using soda lime. So let me write the reagent what we are using. What is the reagent name here? It's soda lime, NaOH. Lime, you know, right? It is a quick lime, CaO. So the combination goes over here as NaOH plus NaOH plus CaO. Is this clear, Hridaya? This is called soda lime. So when you are treating acetic acid salt like sodium acetate, it gives a compound methane and we get sodium carbonate. Clear? Hridaya, it is clear, right?
Yes, ma'am.
Okay, try this reaction by yourself. CH3, CH2, C double bond O, O, Na. I have just written the same. If you're getting confused, no worry. I will write CO. Okay. So what will be the product, Hridaya? Treating with the sodium hydroxide and Na calcium oxide. This is sodium propionate. Yeah, please tell me the product. So same way you are okay. You wanted to take help of this. You have to remove CONA se pura group and NaO from here, the reagent side. So you have to take. You have the notebook pen with you. So all together we are removing. The leftover here is CH3, CH2,
Yes, ma'am.
and this side hydrogen. So this carbon is already holding 3 hydrogen and connected with the 1 carbon, 4 stick around it. But this carbon when get detached from the CONA need one more. So that is balanced by hydrogen. So this hydrogen goes to this carbon and gives CH3 single bond CH3. What do you call this as? C2H6 means ethane. Are you getting? And this which is not shaded in blue, let me shade some different color, yellow color. What will be the product? As usual, same what you have seen in the first reaction. So always the carbon dioxide goes right in a salt form, carbonate, and that is sodium carbonate. Clear, Hridaya? Will you try another by yourself?
Yes, ma'am.
Okay, let's do this then. What happens when sodium benzoate treated with soda lime? So think about it. This whole part always, and this hydrogen will come at this place. So what do you get there? Benzene ke upar hydrogen. That means benzene. It gets its hydrogen back. So formula comes as C6H6. All carbon has hydrogen. Look over here.
Yes, ma'am.
So the formula goes as C6H6. Right?
Yes, ma'am.
Plus, what do you get product as? Sodium carbonate. Are you clear there?
Yes, ma'am.
So sometimes they ask this as the decarboxylating agent. Decarboxylating agent. Name decarboxylating agent. What is the decarboxylating agent name? Soda lime. And the combination you can write in bracket NaOH plus CaO. Clear?
Yes, ma'am.
Okay. So we will finish this chapter and we'll have 5 minutes break. Then we'll start the new chapter, amines. Okay,
Yes,
Rudya?
ma'am. Yes, ma'am.
So two reactions are left. The one reaction we have the naming reaction. It is called the Hell-Volhard-Jelinski reaction. And then we are having the one benzoic acid reaction with the no two actually electrophilic substitution it is. So we'll do with the sulfuric acid and another is the bromine ke saath reaction. So we'll learn and then we'll wind up. Okay, wind up in the sense we'll have some break. Okay.
Yes, ma'am.
Okay, let's learn next reaction. This comes again under the same reaction involving COH and it would be third type. Okay, so now let's see over here substitution reaction it is. Okay, substitution reaction it is called as. So first we have the naming reaction. What is the name of this reaction? Called Hell-Volhard-Jelinski reaction. It's after scientist name, this reaction name is given Hell-Volhard-Jelinski reaction. So what a Hell-Volhard-Jelinski reaction says, carboxylic acid which will contain alpha hydrogen, right? So what is the condition? Carboxylic acid which containing alpha hydrogen, right? They react with chlorine or bromine. ठीक है, the condition is mentioned either the chlorine or with the bromine, and the another they must have alpha hydrogen. ठीक है, they react with this, correct? And this happens in the presence of, how do you identify red phosphorus? In the presence of red phosphorus. So this is the key actually. This reaction always given by the like equation form and asked to complete the reaction or identify the name of the reaction. So remember carboxylic acid we can say, alpha hydrogen also we can identify, the reagents also you can identify, but the third point which is very very specific, it's a red phosphorus, it is not common with all. So if is present, then we can say that goes for the product called the alpha halo acids. Okay, so it produces alpha halo acids. Hydrogen I'm writing. Is this clear? Let's see the reaction over here. RCH2COOH is taken. How this is identified? Because the after carboxylic acid, this carboxylic acid is alpha carbon. Okay? So alpha carbon has the alpha hydrogen over here, isn't it? May the this Hridaya, are you able to understand? Right? This
Yes,
now
ma'am.
reacting with the chlorine, either chlorine or bromine, anything can be taken. But this has to be done in the presence of red phosphorus. Okay? Followed by the hydrolysis, and this will give a product alpha halo acid. Means where halogen will go to alpha carbon, removing hydrogen from that. So we get attached the Cl over here, and H will be obviously over one H because only one H gets displaced, and we get as the product HCl. Are you clear? So how we can understand? Look at over here, Hridaya. I'll help you in understanding ClCl. Okay, just a minute. Okay, this is alpha carbon. Let me name it as a alpha. So here we get, I have just differentiated. I just splitted the two hydrogen in this way, structural form, CH and down CH2. Okay. And now we are taking Cl from it and forming HCl. Okay. And this Cl can come and attach. Are you able to understand now, Hridaya?
Yes, ma'am.
Good. So this is how we form a compound halo acid. What do you call this as? Halo chloro acid. It is. Halo means chloro. Halogen से halo बना है. And halogen families are fluorine, chlorine, bromine, iodine. So we can call it as a alpha chloro acid. What you can call it this as compound alpha chloro acid will be produced. So now Hridaya, you can try this reaction and do this by yourself. What will be the product? Red phosphorus followed by the hydrolysis. Yes, Hridaya, go ahead.
CH3 CHCl COH.
Very good. Plus HCl.
CL.
Correct?
Yes,
Is
ma'am.
this correct?
Yeah.
Okay. Yeah. So now the next and the last reaction where we have the benzoic acid ka reaction, aromatic carboxylic acid reaction, which gives the electrophilic substitution reaction. So here basically aluminium chloride ke saath the which we have a problem, and we will be not be able to show the Friedel-Crafts alkylation or acylation reaction. So there is a reason, we'll discuss that also, no worry. So let's see the first reaction of benzoic acid. Benzoic acid reacts with the compound like sulfuric, concentrated sulfuric, like we call it as a sulfonation reaction. Plus we can say concentrated. Suppose if we have used only sulfuric, then it is sulfonation. But if you have added up nitric acid, then the reaction will be different. So let us take what is there in the syllabus. You have only the one reaction. You do not have the sulfonation. Let us take only our reaction is nitration. So benzoic acid ka we will do the nitration. Let's see this. Then let me write over here. Basically, it's a nitration of benzoic acid. What is the reagent used for the nitration? Concentrated H2SO4 along with the nitric acid. So let me first keep HNO3 and then H2SO4. If only H2SO4, then sulfonate. Clear, Hridaya? Here, this is giving a different substituted product. It does not go to ortho and para position. This is the specific, we can say, a nature over here. So with respect to COOH, okay, Hridaya will do one thing. We have to, like, it does not look good now. So let us make COH over here. So I can consider this is the first, looks good. And here also, anyhow, all identical, no worry, that was also correct. So meta is 1/3, right? So this is the third position. I can substitute over here. Why I didn't go to COH over here and this? You might get confused because always we use this position for the para, na? But if you count with respect to COH, this will come into third. So the concept, numbering concept, if you keep in your mind, then you will never get confused. So meta nitro product you will get. Are you clear? Usually, what do you get? Ortho and para derivative. Here, what are you getting? Meta derivative.
Yes.
Correct. So meta directing group here it is product is formed as second benzoic acid reaction. Bromination. So bromination happens in the presence of bromine. Benzoic acid plus bromine, and this in the ferric bromide is taken, so bromide we will be taking. Okay, whatever you take, that halide you have to keep with the iron also. So we will take same meta directing COH group with respect to this. The third position is meta, so Br goes over here. What do you call this as, Hridaya? Meta bromo benzoic acid. Are you clear, Hridaya? So benzoic acid produces metabromobenzoic acid. Clear? So why Friedel-Crafts acylation or alkylation is not possible with it? So let me explain this. Acylation or alkylation. Not possible. Why? Because let me explain the reason. We have used the catalyst for the anhydrous aluminium chloride as the catalyst for the reaction alkylation and acylation. The catalyst we use as the anhydrous aluminium chloride. So this anhydrous aluminium chloride nature is Lewis acid nature. How it will be? Aluminium के outermost shell में 3 electron. It is trivalent. And chlorine is 7. Correct? So this 1 electron can be kept in front of aluminium and they share their electron and they form covalent bond, single covalent bond. Look at over here. This is done for chlorine and now it is done for aluminium. So you just I will highlight this reason. You can see over here aluminium has how many electrons? 1, 2, 3, 4 and 5 and 6, whereas all the chlorine has completed their octet. So what aluminium shell showing? Incomplete octet. Okay, incomplete octet as per the Lewis concept. Lewis said it is an acid. Why it is an acid? Because it needs 2 more electrons to complete its octet. Correct?
Yes, ma'am.
So when it needs 2 more electrons to complete its octet, this can act as a lone pair acceptor. It can act as a lone pair acceptor. So molecule which acts as the lone pair acceptor called an acid as per the Lewis. like how ammonia was holding one pair of electron with it, so that was called a base. Similarly, that this has a lack of electrons, so will opposite will be called an acid. Did you understand? Did you understand?
Yes, ma'am.
Tell me. Yeah, so this reaction, like we can say, this carboxylic acid group is deactivating and catalyst aluminium chloride bonded to the carboxylic acid. That is the reason we cannot say the compound Friedel-Crafts reaction or alkylation reaction undergo. Okay. So aromatic carboxylic acid do not go for Friedel-Crafts reaction. Why? What is the reason? Did you understand the structure and you have come to know this is an Lewis acid, right? So we can say because, what is the reason? It is very important for reasoning question because, tell me Hridaya, what did I say? Carboxylic acid group is deactivating. ठीक है? Deactivating and catalyst AlCl3. What is the nature you have seen of AlCl3? Lewis acid. Bonded to the. So catalyst का function क्या होता है? Catalyst only to enhance the rate of the reaction. But यहाँ पर catalyst is acting, it is reacting. So that is the problem. Are you clear?
Yes, ma'am.
That's all. Now we can have some break and we are done with our carboxylic acid. Means the biggest chapter you can see in your syllabus is this is the chapter. So we have done with this chapter. I'll send you the notes, both the notes, today's notes. Okay, so we learned all the chemical properties. So one day, not today, the summary part, or you want the today itself to summarize all the chemical reaction in a flow chart.
Oh, yes, ma'am.
Will be fine, or I will send the flow chart. That's it. You can do it by yourself. What do you
Oh,
say?
ma'am, anything's fine.
Because we don't have enough time, na, Hridaya? That's what I'm thinking. We have to complete the chapter which holds the maximum marks. We have to complete first that,
Yes, ma'am.
right? Okay, Hridaya. So have some break and then again we will join. I would extend little class today, like 10 to 15 minutes. So yesterday's time we can compensate. Can we?
Yes, ma'am.
Just to 10 to 15 minutes. Okay.
Yes.
Yeah. Thank you, Hridaya. So let's begin the new chapter. This chapter name is amines, the new functional group after carboxylic acid. Okay. So the amines, these we say it's a derivative of ammonia. So before going to amine, let me tell you how many marks will be given to amine chapter. Basically 5 marks. And this chapter question, it's not from 1 mark or like that. You will have directly 5 marks question in the part of D. Okay. In that part of D, you will have the question number like Roman numeral 5, you can see there will be given the marks. Okay. So
Yes.
5 marks total will come over here in part D. Now let's see amines. What are amines? If you talk, amines are derivative of ammonia. So basically they are derived from ammonia. Let's see how. Now nitrogen valency is 3. So I kept around the nitrogen 3 step. 1, 2, 3, right? And you know very well this is a lone pair of electron which is in unshared form, right? So here in this compound amines, when we are talking in this, every time one alkyl group, right? Alkyl in the sense, suppose if you get R, R can be anything, can be, CS3, C2H5, anything it can be, right? So this gets added, and every step hydrogen will be removed. So what do you get as the compound? CS means R gets attached over here and hydrogen gets removed. This is amine, right? And as the concept says, nitrogen contains two hydrogen, right? So since it is containing two hydrogen atoms, we call it as a 1-degree amine, right? Again, in this compound, we'll add alkyl by removing hydrogen. So look at over here, nitrogen, taken one more R, and only one hydrogen left now. So what do you call this? It's 2-degree amine. Now in the final step, we are going to add R and remove hydrogen. So what do you get as the compound over here? So what you observe, there is no hydrogen. So you call it as a 3-degree amine. Did you understand? So basically amine derived from ammonia. Did you understand the concept of 1, 2, 3 degree?
Yes, ma'am.
Okay, let's see example. 1 degree aliphatic amine. This is an example. Okay, we call it as a methyl amine. IUPAC में what will be the rule? Let me talk simultaneously. IUPAC rule. For primary aliphatic amine, IUPAC rule goes as alkanamine. What is called this as formula? Alkanamine. It means it has a suffix. What that suffix is? AMINE, amine. Right? So it is applicable only for 1 degree aliphatic amines. So we can call it as a methane amine. Right? Now question arises is over here. Do we need to keep the E of methane as it is or remove? So we must remove because amine is getting added up. So this is the IUPAC name of this compound. Did you understand?
Yes, ma'am.
Next compound, I can write like this, right? In a formula, in a condensed form. What you need to focus, next to nitrogen, how many hydrogens are present? If it contains 2, then it belongs to the same category, 1 degree aliphatic amines. Clear? You are able to identify this is 1 degree aliphatic amines. Why? Because the nitrogen has 2 hydrogens. Clear? Now, how many alkyl groups are there? Total 1, 2. Why did I start from this side? Because nitrogen nearest to this carbon. So this carbon consider 1 and then 2. Since there are 2 carbon, we can call it as a ethane. E will be dropped and amine will be added up. Hridaya, are you clear?
Yes, ma'am.
Okay. Next one you try by yourself. Which type of amine is this, Hridaya? Hridaya, tell me which type of amine is this?
Is this?
Yeah.
Is this?
1 degree. 1 degree aliphatic amine. Which type of aliphatic amine is this? 1 degree aliphatic amine. Aliphatic का मतलब कि hydrocarbon single straight form or in branch form, not in a aromatic ring form. Got it?
Yes, ma'am.
Okay. Give the IUPAC name.
Uh, is it propanamine?
Exactly. Propanamide. Well done. So you have learned about the 1 degree aliphatic amine. Let's do 2 degree aliphatic amine. What will be the IUPAC rule and how are they looking? Example, you will first see. The general formula, we have seen that nitrogen in the center, which holds one hydrogen but contains two R with it, right? It means R2NH. This is the formula, right? The structural formula is this, will be this, and the formula, molecular formula, I would say, will be this, okay? So we can say it contains two R, right? So secondary, or what we can consider as 1H. So secondary or 2 degree aliphatic amine. Let's see the example over here. When you write the example NH, right here you write CH3, here you write CH3, and here you write one hydrogen. So what do you say? This is the one hydrogen containing nitrogen compound. So it is 2 degree amine. We can write even 2 degree amine, no worry. Okay. So how many alkyl groups do we have? 2. So let's learn the IUPAC rule, how it will be applicable for these compounds. Okay. So one goes as the substituent. One goes as the substituent. Other comes as the hydrocarbon chain, parent carbon chain. Other carbon will be considered as a parent carbon chain. It means root word. Are you able to understand? With which functional group will be attached? AN or EN, like that. Clear?
Yes, ma'am.
So this is applicable for 2 degree. What is the rule over here? Then, and here, yeah, one more thing. The number of carbon, if it is going in equal number, identical alkyl. Identical means same number of carbon present in both the sides. Identical alkyl groups. This is applicable for that. Okay. N alkyl formula. N alkyl alkanamine. ठीक है? What is N for? N for nitrogen. Means alkyl group is attached to nitrogen. Got it? So we can write for this compound N-methyl, and next hydrocarbon is also one carbon, methanamine. Hridaya, are you clear?
Yes, ma'am.
Let's see another different alkyl group के लिए. Okay, one example we will try and then we'll go for different. ठीक है, Hridaya? Which type of amine is this? 1 degree or 2 degree or 3 degree?
2 degree.
Yes. Why? Because it has one hydrogen attached to nitrogen. Clear?
Yes.
And we have 2 alkyl groups now. 2R. Right? Okay, Hridaya. Now we will select this 1 and 2. Any one you can go for parent carbon, and this is as the substituent we can go for. Right? Hridaya, are you clear? So this will be N-alkyl and this will be alkanamine. So what is the name? 2 carbon ka what is the root word? Eth. So eth के साथ alkyl का YL add up, तो what do you call as ethyl? Clear? ETHYL. So N substituted ethyl, the prefix or the substituent will be written first. Here, instead of writing number, what we are writing as nitrogen. That's all. This is the difference. I have just enlarged the screen. Ethenamine. So you can see clearly. Ethenamine. Are you able to understand, Hridaya? This is applicable for identical. Are you clear? This is 2 carbon atom ke liye we have used the root word and the suffix alkyl ka YL, that is why the name comes ethyl. And similarly, you know how to apply for the root word ethane, write AN because single bond, amine is the suffix. Hridaya, this is clear?
Yes, ma'am.
Let's learn for the different alkyl group. So if we have compound where we have one attached with the CH2 CH3, other side we have CH3 just, and here is the hydrogen. Secondary I'm talking to 2-degree amines we are talking to. Okay, and applicable for the different alkyl groups. You can see this holds 2 hydrocarbon, and this here we have 1 carbon. The lesser carbon go for the substituents always. Less number of carbon, right, will always be a substituent. Are you clear, Hridaya? More number of carbon will go for parent carbon chain. So 1 and 2 always go with the parent carbon chain. Hridaya, are you able to understand?
Yes, ma'am.
Okay. Now what will be the name? Same rule, but here the little preference goes N-alkyl alkanamine. Got it? So we call it as a N-methyl. Substituent is methyl. And the root word is eth, N amine. Are you clear now?
Yes, ma'am.
Will you try one example?
Mm.
This is 2-degree because it holds 1 hydrogen with it. So it is obviously 2-degree amine.
Yes, ma'am.
Now give the IUPAC name. Here we have less carbon. Here we have more carbon. So identify. Follow the alkyl alkanamine rule and write the name. 2 carbon eth root word. 3 carbon called prop.
N-ethyl propanamide.
Exactly. N-ethyl propanamine. Well done. Now let's learn 3-degree. So 3-degree amines may we do not see any hydrogen present to nitrogen. All the sides we will see methyl. Means alkyl. I meant to say, sorry. Can be anything, not only methyl. So rule goes over here. Either they can be identical. So let's learn for the identical first. Example. This is the, so N, right, N comma यहाँ पर, and we'll write because both are identical, so we can use the prefix di. Okay, alkyl alkanamide. So any one can be considered as a hydrocarbon chain over here. Are you clear? So only the difference is N will be written 2 times, for one N for this methyl, another N for this methyl. Okay, clear? And di word we have used for two, alkyl, methyl, methenamine. So one is considered as a hydrocarbon chain. Clear, Shradya? So this is substituents, substituents. These two are as the substituents, means prefix. Clear? And these substituents are identical. That's the reason both are kept together and taken a prefix help di and used together. So what will be called as NN dimethyl methenamine. It is possible with the identical. Clear?
Yes, ma'am.
Okay. Now look at over here. Even this, suppose if I increase the number of carbon, I may increase the one side and that side go for a hydrocarbon chain. This also follows the same rule. Anyhow, our groups which are attached, the lesser number of carbon, those substituents are identical, isn't it? So follows the same rule. Right? And this is as the hydrocarbon chain, parent chain. So 1 and 2. So what would be the name? N comma N dimethyl, right? Ethenamine. Hridaya, it is clear to you?
Yes, ma'am.
Do this example. Both are, all are safe, no worry. Hridaya, go for this name. Any two you can consider substituents. 2 carbon eth. Substituents will be alkyl. So YL suffix will be taken and added with the root word. So tell me the name.
N di ethyl ethanamine.
Superb. Very nice. Good. Okay. Now let's learn the different groups as substituents. Okay. For 3-degree amine. So go over here, the rule goes over here. C2H5 है एक जगह CH3 है. Even I can keep C2H5 over here, no worry. So Hridaya, 2 will be considered as the substituent and 1 will be considered. Why we are not able to take long carbon? Because which में nitrogen आ रहा है ना, center bound we are getting nitrogen. So there is no continuity of carbon, isn't it? Carbon chain should be continuous carbon chain for a parent carbon chain. We don't have that. So obviously here will be rule changed so little bit. Where we are getting the carbon, more carbon, that side we consider as a parent. So let us keep this as the parent carbon chain and rest all 2 as the substituent. So these 2 are substituents, but both are different. Then we can go for alphabetical order. Okay? So this this substituents start with the E because the name is ethyl, and this starts with the letter M, methyl. So in alphabetical preference, alphabetical order, now here it will follow alphabetical order. So E comes first, correct? Then M.
Yes, ma'am.
So we write first over here. The rule goes N alkyl, N-alkyl alkanamine. So one L for the preference which gives more, and then another N for the lesser one, and then root word, and then an amine. So let's write the IUPAC name of this compound. N-ethyl, N-methyl, ethanamine. Are you clear? Hriday, are you clear?
Yes, ma'am.
Okay. Can we do one example?
Yes,
Do this. Next. This is 3-degree amine because does not have hydrogen with the nitrogen.
N-ethyl
Very good.
and methyl propanamine.
Very nice. N-ethyl, N-methyl propanamide. Now we are done with the IUPAC as well as the examples as well, right? So what would I do first? I'll give the um, all together examples. I will give first. Identify 1, 2, 3 degree Ketra, and then we go for IUPACs, right? I will help you in that because you are a beginner, right? You have started just now. So no worry, I'll help you. Don't hesitate. You just ask me, okay? So let's identify first. Identification, test, identification of 1, 2, and 3 degree aliphatic amines. Is this clear, Hridaya?
Yes, ma'am.
So I'm writing examples and then let me finish examples, then we'll go for discussion. Just keep your concept clear. Wherever nitrogen, that should contain 2 hydrogen for 1 degree, 1 hydrogen for 2 degree, no hydrogen for 3 degree. No worry, right?
Yes, ma'am.
Yes, sir. There. Go ahead by now. This compound. So where you need to focus, let me highlight. Just a minute. Very sorry. Hmm. 1, 2, and 3. Which type of amine? The first one, Hridaya?
Uh, 2, 1 degree.
Yeah, 1 degree. Second one,
Uh, 1 degree.
Well done. Next one.
2 degree,
Well done. Next one.
3 degree,
Super. Next one.
2 degree,
Super. Next one.
2 degree,
Very good. Next one.
3 degree.
Super. You are able to identify now amines?
Yes, ma'am.
The concept you remember, 2, 1, no hydrogen. For 1, 2, 3 respectively. Okay, can we go for IUPAC name? It will take time, no problem. 1 degree alkane amine के लिए, sorry, 1 degree amine के लिए rule is alkane amine, right? So go ahead with the number of carbon, 1 and 2. So root word will be eth. Name it.
Ethanamine,
Very good. Next one. Least position will be given to the group functional. No problem, left, right, any side you can go. So 2 propanamine or propane 2 amine you can call, isn't it?
yes, ma'am.
It is clear, Hridaya? Second one you try. This rule follows N-alkyl alkanamine. Both are identical, parent and the substituent. So N-substituted alkyl and calamine. So this you can consider as a parent chain, this as the side chain, means prefix. Now you name it. 2 carbon called eth. So N-ethyl ethanamine. It is clear, Hridaya?
Yes, ma'am.
Okay. Methyl we have over here, right? Since 2 are less identical, so can we go for NN dimethyl? And then root word? Help me with the root word, Hridaya.
Yes,
Ethanamine. Right?
yes, ma'am.
Next one. N-alkyl alkanamine. So this carbon is long carbon. This is considered as a substituent. How many carbon in the substituent? 1. And the substituent will not be represented by position, any position. It is N substituted. So name it. N, first we will be written. Methyl, root word, ethanamine. No worry, it
Yes.
happens. It will take some time.
Yes.
So now here we go. N substituted again, the same we have, but number of carbon is more. So you try this by yourself, Hridaya, taking help of the previous example, fifth one.
N-methyl propanamine,
Yes. N methyl propanamine. Yes, Hridaya. Go ahead with this. No worry, you can go ahead like N, comma N, dimethyl, first will be written. Okay? And then what is the position? 1, 2, 3, 4. So third position you have methyl, 3 methyl And the name of the hydrocarbon, butanamine. Is this clear?
Yes, ma'am.
Good. Any confusion in this? Anywhere?
No, ma'am.
No, right? Can we go for preparation?
Yes,
Can
ma'am.
we? Okay. So you want break or can we continue for 10 minutes?
Ma'am, we can continue.
Very good. Let's begin with the next topic, preparation. Preparation of amines. Okay. So how do we get the amine? Here we have mostly preparation in the aromatic amines and the aliphatic amine. Together we have to learn, but aromatic will be more. Okay. So let's begin first reaction from nitro compounds. Okay. So from nitro compounds, how do we do this reaction? And let's see over here. We write the compound benzene nitro group. Okay. And we do the reduction hydrogenation, basically called as, in the presence of palladium, and we heat it. That's it. Actually, hydrogenation happens in the presence of nickel, platinum, or palladium, right? So we took over here palladium. Okay. So the product over here forms, we get the aniline. NO2 group changed to aniline. So this is the 1 degree aromatic amine. Okay, you can see 2 hydrogen atom over here, Hridaya, with the nitrogen attached. Aromatic ring is, so it is called a 1 degree aromatic amine. Clear? By general name, we call it as aniline. Right? Plus, we say this release of water molecule from here. Are you clear, Hridaya?
Yes, ma'am.
Okay. The same, this is the one reaction we do. Second reaction, we do take the nitro group. This is called as the nitrobenzene. Take the nitro group and do the reduction in the presence of metal. Okay, so the reduction symbol is in a big bracket, nascent, it is representing hydrogen, which is needed for the reduction process. Addition of hydrogen happens in reduction. Concentrated HCl के presence में metal, you know, it's a good reducing agent. So it gives out the aniline. That's all. Nitro group goes to NH2 group. This is only getting converted in both the reactions. You can see. Correct? So we get from nitrobenzene, aniline, both the ways. Any one way you can say the preparation possible, right? Preparing aniline. Here the product will be again water, 2 moles of water, because it's a nitro. Sometimes they ask, do we have other metal also? Yes, iron. Either you take the tin or you can take iron in the presence of HCl. Clear, Hridaya?
Yes, ma'am.
Okay. So aromatic aromatic amine, first preparation is from nitro group that we have taken as the nitrobenzene, obviously because it's a nitro compound. Correct? So we have taken it. Now the next reaction, aliphatic, let's see here, that is ammonolysis. We call it as ammonolysis of the compound, like 1 degree amine will be going to 2 degree, 3 degree, and then the quaternary ammonium. So exactly like how I taught you in the beginning, derivative. So the second is we are learning ammonolysis. It means ammonia will be formed first 1 degree amine, RNH2. This is called 1 degree amine. 1 degree amine will be treated with the haloalkane and HX will be out, and this forms the R2NH, right? Similarly, again, haloalkane will be treated, HX will be moved out, R3N will be formed. This is 3 degree amine. This is 2 degree amine. right? And then 3-degree amine can again be treated with the RX, but there's no hydrogen, so it will not release HX. Instead of that, it will form the salt, which is called the quaternary salt. Four are there, four we call the quaternary. Ammonium salt. It is clear? It is clear?
Yes, ma'am.
Okay. Hridaya, I need just a few minutes, 1 or 2 minutes I may take. My one student is just logging in for writing test. So let me in and give the paper to her. Okay.
Yes, ma'am.
You have received the question paper, right? Open the phone.
Yeah, yes.
Yeah. Keep your camera on.
Yes.
Yeah. Hridaya, can you hear me?
Yes, ma'am.
Yeah, let's begin. So here we go. So quaternary salt is formed. So 1-degree amine, 2-degree amine, 3-degree amine, you have seen how reaction takes place. If I open this reaction chain and then show the reaction, would be more clear to you. You can see how Rx is treated with this. So I would write Rx ka X part towards to H so that HX can go and R can get substituted. This is how, right? Hridaya? So R and N R comes over here and H plus we get the HX out. Correct, Hridaya? Then again this compound is taken. This is called the R2. Correct, na? Together. 2R. Look at over here. R2 and 1N and H. So R2NH. Clear, Hridaya? This will be taken again and treated with the RX. Okay, so what I'm going to do, Hridaya, here I'll keep H and here I'll keep R. So I can show you removal of HX and R can come over here. Are you able to understand, Hridaya? Please respond.
Yes, ma'am.
Plus HX go out. Okay, so this is how your 1-degree amine, say 2-degree we get by treating with the haloalkane. What do you call the RX as? It's a haloalkane, right? So
Yes, ma'am.
1-degree amine treated with the haloalkane gives 2-degree amine. Then 2-degree amine will be treated with the haloalkane. Again another mole Rx will be taken and it produces 3-degree amine. Are you able to understand, Hridaya? Then
Yes,
again
ma'am.
3-degree amine will be treated with the Rx. So look at over here. This time we cannot show the removal because no H left with the high nitrogen. It is 3-degree amine, isn't it? So what happens? Altogether gets substituted and the coordination bond now at this time. So we get the R ka substitution with the N over here, X and R over here and R. What do you call this as the compound R4N, right? Plus an X. So this since this goes in, so we get over here lone pair is now shifted. Na? This is how we get a compound. What do you call this as? Quaternary salt. Why it is quaternary? 4 alkyl is there. And why it is salt? Because both the ions are present. Did you understand?
Yes, ma'am.
Okay. What happened, Shreya? Yeah, any confusion?
No, I'm just reading the question.
Okay. Okay, so quaternary ammonium salt we have got from here. You have, I hope you have learned how the production happened, right? Hridaya, you have learned, right? This is how the production will be formed and monolysis will be happening. Now Gabriel, next we'll do the Gabriel, just 2 to 3 minutes. I'll take this reaction over, then we'll wind up the class. So Gabriel thalamide synthesis, the third reaction we have to learn. Actually, Gabriel thalamide reaction, it is said that it's a looking like preparation of aromatic, but it is not aromatic. Taken the aromatic reactant, but product as the primary aliphatic amine is produced. So we take as the thalamide. What is thalamide? In this phenolic group, C double bond O and O over here, but nitrogen, because nitrogen amine group amide we are taking now. So here, so we call it as a thalamide. ठीक है, we take the thalamide and treat it with the KOH alkali solution. So this gives out the water, ठीक है, and potassium gets substituted. H and OH goes out and K gets substituted. So you get the potassium substituted compound thalamide ka. So C double bond O, and here we get the K, C double bond O. Just a minute, H is going out, N will be there as it is, and K. Okay, Hridaya, then it will be treated with the halide, haloalkane I meant to say, which gives out the KX out. This go out in the form of KX both. Okay, and R gets substituted over there. So we get KS out and C double bond O, N, R substituted over here, C double bond O. Hridaya, are you able to understand?
Yes, ma'am.
This compound again treated with the 2 moles of the sodium hydroxide. Why? Because we want this has to be right out. So when we are treating 2 moles, so we get as the compound RNH2, which is primary amine. We get primary aliphatic amine, and then byproduct may what do you get? The Na go over here, this whole comes out, so Na go and occupy that place. So C double bond O Na will be formed this side, O minus Na plus, and this again this will be O minus Na plus. Is this clear, Hridaya?
Yes, ma'am.
So R ki jagah we can take CH3 methanamine and we can show the reaction. That's all. We'll connect tomorrow again at the same time. Can we, Hridaya?
Yes, ma'am.